Hello everyone, welcome to the Group 18 interim presentation of ME 452 and ISD 528. Our team project is Analysis and Redesign of Robotic Arm Gripper. Our team members are Shri, Dhiral, Noah, Persha, and Kashyap. Grippers are devices that enable robots to pick up and hold objects. They are a subassembly for a robotic arm. When combined with a collaborative industrial robotic arm, grippers enable manufacturers to automate key processes such as inspection, assembly, pick and place. To the right side, you see the picture of the gripper. The end effector features are two parallel jaws with flat edges. They open and close, they clamp onto the part, keeping it stable with force. Our primary customers are automotive, electronics, manufacturing, medical, food processing industries. The secondary customers that we considered for this project based on the size and shape of the robotic arm gripper are science labs for the production of tiny tubes and cosmetic industries for production of sample bottles. To better understand the functioning of a robotic arm gripper, we did a fast diagram. The task function being hold or grip objects, the primary basic functions being move and release objects. The supporting functions mainly focusing on increasing reliability and enhancing the product.
Hello, my name is Dhiral. I will be presenting the CAD design as well as the fishbone diagrams. So as you can see in this slide, we can see there is a 3D exploded view of robotic arm gripper which consists of 15 number of parts, which do exclude fasteners. There are around 11 fasteners which are presented in the BOM in the further slides. Well, to understand the assembly process, the fishbone diagram makes the process easier. As you can see, there are two types of fishbone diagrams available. The one is based on the base plate, which has around 8 number of steps, while the second one is the upper wrist plate, which has around 7 steps. The second one is more feasible and efficient compared to the first one, but these are the two options that are available for the assembly.
As described before, the main functions of the robotic arm gripper could be listed as picking up, directing, and placing objects. These tasks will be common between all potential customers, primary and secondary. However, the type of gripping varies based on the customer group and their needs. As a result, we have two platform modules, the wrist module and the claw gears, common between all customers. Also, we have two variant modules which will help in assisting different customer groups. First, we have the variant grippers. The tight gripper, which is shown in the picture, serves our primary customers, such as industrial manufacturers. We can also offer custom soft grip with a different set of grippers for our secondary customer group, consisting science labs or cosmetic manufacturers who work with fragile tiny objects such as glass tubes. Also, we can offer servo base or rigid base plates based on the customer's need for wrist movement. Based on the modules described in the previous slide, we can have 4 different combinations of final assembly product based on the choice of wrist movement and tight or soft grippers. The desired assembly process to allow delayed differentiation requires to start with wrist movement and the gears module. Then move to base plates module, which there are 2 options for it, rigid base and servo base. This will allow time for the customer to choose the type of grippers at the end, because choosing the gripper type might need some extra attention and time. There is also potential for developing other types of custom grippers in the future based on the customer needs. Therefore, delaying the claw grip assembly to the last step will be beneficial in terms of delayed differentiation.
We use the functional component map in order to map the 3 terminal subfunctions from the fast diagram against the 8 main components of the gripper. Looking at the functional component map, we notice that most of the components are mainly connector pieces whose purpose is to provide structure or support to the gripper. The three main functions are mostly carried out by the servo motor, the claw gear, and the gripper. We use the bill of materials in order to tabulate our data regarding each individual component's material, manufacturing process, assembly process, and unit cost. We used various methods taught to us in class and some external websites such as Hubs and an injection molding company's website in order to get the cost estimates. Subsequently, we used each individual component cost, added them up to get the total cost of the gripper, excluding fasteners, which came out to be $10.80.
To reduce this unit cost per part, we are going to redesign each part of the gripper. For example, combining the servo to claw pin and servo connector plate parts into one single part. We also plan to redesign the gripper right and left for easier manufacturing and to have multiple designs for both our primary and secondary customers. Like Daryl mentioned earlier, we have 11 types of fastener on this slide and the next. We plan to eliminate all of them except for the screws which will connect directly to the servo motor. In total, these fasteners come out to $2.48 for each gripper that we make. Thank you for listening to our presentation. Are there any questions or suggestions?